On October 21st, 2025, something changed. Independent astronomers scanning the night sky as part of their routine tracking of celestial bodies noticed an anomaly that, at first, seemed almost too improbable to believe. The Comet 3 Atlas, which had vanished from the astronomical radar years ago, was back. But it wasn't where anyone had expected it to be, and it was moving far faster than predicted. The comet, which had first appeared in the summer of 2018, was thought to have burned out, leaving only a faint trail in the cosmos. Its trajectory had been analysed and accounted for. There were no signs that it would return anytime soon, and certainly no indication that it could cause any kind of danger. Yet, here it was, reappearing from the farthest reaches of the sun's shadow. The data showed its path was no longer following the gentle curve that scientists had forecasted. It was erratic, unpredictable. This discovery wasn't made by NASA or the large space agencies that dominate the scientific community. It was amateur astronomers, working with their own small telescopes, who first noticed the discrepancy. A group of enthusiasts in the southern hemisphere had been scanning the sky when they saw something unexpected, a bright speck of light in the sky that shouldn't have been there. They immediately cross-checked with the publicly available tracking systems, confirming that it was indeed the long-lost comet, now coming into view from behind the sun. But it was not moving in the way anyone had predicted. The news spread like wildfire through online forums, with experts suddenly pulled from their comfort zones to analyse the data. At first, the discovery was written off as a mistake, a misinterpretation of light reflection or a new satellite. However, as more amateur astronomers confirmed the finding, the tension began to build. The comet 3I Atlas was coming back, and it wasn't behaving like any comet before it. This was no longer just a scientific curiosity. Something felt wrong. The data was unclear, and the initial reports were filled with a sense of foreboding. If the comet was moving this quickly, was it on an orbit that would bring it dangerously close to Earth? The question lingered in the air, unanswered. But one thing was certain. The astronomical community had just been thrust into an unknown territory, and the stakes were higher than anyone had imagined. The story of 3I Atlas began back in early 2018. Discovered by the Atlas, Asteroid Terrestrial Impact Last Alert System, survey in Hawaii, it was initially thought to be a small, insignificant object in the vastness of space. Atlas, an advanced sky survey system, was designed to detect objects in space that could potentially pose a threat to Earth, such as asteroids or comets. When 3I Atlas was first identified, it wasn't unusual for a comet to be catalogued. After all, the solar system was teeming with these icy wanderers, most of them travelling along predictable paths in the void. However, 3I Atlas was different. Its trajectory was anything but typical. It wasn't moving in a perfect elliptical orbit like most comets. Instead, its path seemed strange, like it had been forced to curve in an unusual way. Its first pass near the sun had been close enough to cause some minor confusion, but nothing that raised alarms. What was more unusual, however, was its origin. The 3I in its name signified that it was an interstellar object, a first for any known comet. It wasn't a native object from within our solar system, but rather something that had wandered into the sun's gravitational influence from another star system entirely. This detail intrigued scientists. Interstellar objects were rare, and 3I Atlas offered a tantalizing glimpse into the cosmos beyond our solar system. Its rapid movement, combined with its strange trajectory, marked it as a curiosity for astronomers. The comet was given little more than a passing mention in the media, largely because it appeared to follow the same predictable path as any other comet, and it didn't seem to pose a threat. But now, years later, the story was different. 3I Atlas was back, and this time, its unpredictable behaviour was far more than just a scientific curiosity. The trajectory that was initially thought to be stable had shifted. The comet, now returning from behind the sun, was exhibiting strange gravitational anomalies. Its speed had increased unexpectedly, and its orbit had changed course. What had initially been categorised as an unimportant celestial visitor was now something far more dangerous. NASA had been alerted. But with so little known about this strange object, the data was sparse, and the implications were still unclear. Yet, as independent astronomers and experts analysed the new data, the unsettling reality began to set in. This wasn't just a returning comet, It was something far more unpredictable, and possibly more dangerous. NASA's initial response to the return of 3I Atlas was measured, as it typically would be for a comet that had simply reappeared from the sun's shadow. Comets had always been a part of our solar system's makeup, and they were not typically a cause for alarm. But as soon as the first official reports came in, it became clear that 3I Atlas was not behaving according to the expected norms. Scientists at NASA's Jet Propulsion Laboratory, JPL, were initially confident. They were dealing with a known object. After all, 3I Atlas had been studied before. Its path had been charted, its speed measured. But as the comet began to re-emerge from the sun, things started to look off. The trajectory, which was supposed to be stable, seemed to shift in unexpected ways. There were moments when the comet appeared to be accelerating beyond what was previously considered normal for a typical solar approach. While no one wanted to jump to conclusions, the data raised questions that couldn't be ignored. The comet wasn't just another wanderer through the stars. It was now exhibiting behaviors that were unheard of. The gravitational pull it was exerting seemed out of place. The speed was increasing. The orbit was tilting in a way that defied understanding. Was this the result of an unseen force, or was the comet itself not as simple as it appeared? As NASA began to analyze the data more closely, an unsettling thought began to emerge. What if this wasn't just a rogue comet passing through? What if 3I Atlas was on a collision course with something far greater than Earth? What if it was a precursor to something much more significant, a cosmic anomaly that was about to reveal itself? The team at NASA was on alert, but there was no immediate cause for panic. The comet was still far from Earth, and it was likely that it would follow its predictable path. However, the scientists knew that this strange behavior was something they couldn't ignore. There was something about this comet that felt different, and it was only a matter of time before the truth was revealed. The deeper NASA dug into the tracking of 3I Atlas, the more unsettling it became. The comet was no longer behaving like a typical object passing through the solar system. It was as if its very nature was shifting before their eyes. But there was one thing that didn't quite add up. The official data was at odds with the independent tracking being done by amateur astronomers across the globe. For weeks, NASA had been working with the data they had, and everything pointed to a safe, albeit unusual, passage of the comet. Yet, when independent astronomers began comparing their results with NASA's, they realized something was off. The discrepancy was subtle, but undeniable. The comet was moving faster, further, and in a completely different pattern than the official data suggested. What was causing the deviation? Was it simply a matter of faulty equipment or poor data interpretation? Or was there something larger at play? NASA was forced to confront the unsettling possibility that they had missed something crucial in their calculations. Amateur astronomers, working with more limited tools, began to find new anomalies that official tracking systems had failed to detect. There were strange bursts of energy emanating from the comet, inexplicable spikes in radiation levels. These were the types of details that should have been detected by NASA's sophisticated equipment, yet it appeared they had slipped through the cracks. Why was NASA missing these signals, and what did they mean? The comet, once thought to be a simple wanderer through the solar system, was now becoming something far more mysterious. Its rapid acceleration, the changes in its orbit, and the strange bursts of energy were all clues to something much bigger. What had started as a small comet passing through had now grown into a cosmic enigma, one that NASA and the world was struggling to comprehend. On the morning of November 5th, 2025, 3I Atlas reappeared fully from behind the sun. The moment was both exhilarating and terrifying. NASA had been waiting for this moment, but as the comet emerged into view, the true implications became clear. The data confirmed what had been suspected for weeks. 3I Atlas was no longer on its predicted path. It was accelerating. Its orbit had shifted in a way that suggested it was not just passing through the solar system, it was being pulled in by something larger. Something was influencing its trajectory. But what? NASA's team of scientists who had been cautiously optimistic in their initial assessments were now in full crisis mode. The comet's proximity to Earth was closer than they had anticipated. It was as though the object was being drawn toward Earth, yet no one could explain why. Was this an accident? Or had something triggered this change? The first terrifying assessment came from NASA's lead astronomer. The comet's path suggests it could get dangerously close to Earth. We need to prepare for all possibilities. The fear was palpable in the room. What had once been a routine comet observation had now become a life-or-death race against time. The implications were enormous. Could this be the first of many unexpected cosmic phenomena? Would this comet's appearance herald a new era of cosmic threats? The world unknowingly was on the brink of a moment that would change everything. The data coming in was beyond what NASA had ever imagined, and it was only getting worse. As 3I Atlas drew closer to Earth, it began to show signs that could no longer be dismissed as irregularities. The comet, which had been casually studied by astronomers in the past, was now at the centre of intense scrutiny. The trajectory it was following was far from what had been expected, and every new piece of data seemed to bring more bad news. For weeks, the comet had been on NASA's radar. Scientists had watched as it shifted unpredictably, but they still hoped it would remain within a safe orbit. Now, as the comet approached the inner solar system, its velocity had exceeded anything anticipated. The comet was not only speeding up, it was also showing signs of a strange gravitational pull. Something was affecting its course, but what? Dr. Michael Harrington, an astrophysicist at NASA's Jet Propulsion Laboratory, was one of the first to make the chilling realization. He spent hours poring over the data, cross-referencing every possible variable. The comet's path was erratic, but worse, it was accelerating as it neared the inner planets, something that wasn't supposed to happen with such a distant, cold object. Harrington's hands trembled as he ran the calculations again. This was no ordinary comet. He pushed his chair back, staring at the screen in disbelief. The comet wasn't merely passing through the solar system, it seemed to be coming toward Earth, as if it were being drawn in by an unseen force. With this discovery, Harrington knew that NASA could no longer treat this as just a cosmic curiosity. This was potentially a threat, and they needed to act fast. He immediately notified his superiors. The sense of urgency spread like wildfire throughout the agency. As the news began to leak to the media, the public's awareness of 3I Atlas intensified. What was once a quiet curiosity among astronomers became a topic of national concern. Public forums were flooded with questions. What did this mean for Earth? How much danger were we really in? The comet was expected to pass closest to Earth within months, but it wasn't just its proximity that was concerning. It was the growing evidence that this was no ordinary comet. Its behaviour, its trajectory, its speed, everything pointed to something far more dangerous. It wasn't long before other experts began to weigh in, and the public's anxiety began to mount. As the data continued to roll in, NASA's fears grew. The comet 3I Atlas wasn't simply moving closer to Earth, it was behaving in ways that defied explanation. What had initially been considered a simple anomaly became something much more perplexing. The comet's movement was inconsistent, erratic. It didn't follow the expected arc, and it seemed to shift with increasing speed. It was almost as if the object itself was being influenced by something outside the normal laws of physics. Was this just an unusual comet, or something far more ominous? Dr. Alice Thorne, one of NASA's leading experts on interstellar objects, began to investigate the strange fluctuations in the comet's trajectory. She had seen her fair share of odd celestial phenomena in her career, but nothing quite like this. She found that the comet's speed had not only increased, but its direction seemed to subtly change with each new observation. It was almost as if it were being steered. The question was, who or what was doing the steering? What struck Thorne as most unusual, however, were the bursts of energy coming from the comet. Unlike the faint tails of dust and gas typical of comets as they heated up near the Sun, 3I Atlas was emitting what appeared to be high-frequency signals. These signals were not simply traces of ionized particles or magnetic fields, but highly concentrated bursts of radiation that could potentially disrupt electronics and communications. Thorne's mind raced. Was this comet alive in some way, emitting signals like a warning? Or was there another force at play here? Could this be something engineered, perhaps even from beyond our solar system? Her findings were disturbing. The radiation coming from the comet was far more intense than expected, and it wasn't following the usual patterns of cometary emissions. The idea that the comet was a warning sign from deep space began to take hold in Thorne's mind. Could this be something more than a natural occurrence? Was it possible that something far larger was at work, something that humans had never before encountered? The signals were unmistakable. They were not random. And if they were not natural, what did that mean for Earth? The comet, through our Atlas, was quickly becoming more than a curiosity. It was turning into a puzzle, a cosmic enigma that was slowly revealing an entirely new dimension to space that humanity had never before considered. Could it be that this was not a comet at all, but some kind of cosmic anomaly, or even a harbinger of something greater, something more ominous? As the world began to take notice of the potential danger posed by Thri Atlas, space agencies around the globe sprang into action. The European Space Agency, ESA, Japan's JAXA, and Russia's Roscosmos all issued statements expressing concern over the comet's unusual behaviour. While NASA took the lead in tracking and analysing the comet, it was clear that the global community was united in its focus on this celestial anomaly. In Europe, ESA's Director of Space Science, Professor Amelia Hartmann, worked closely with NASA to coordinate a global effort to monitor the comet. Her team was already working on refining their data models to predict its exact trajectory. Meanwhile, JAXA, Japan's space agency, initiated a plan to launch a satellite that could analyse the comet's radiation more closely. It was clear that the comet's erratic path had the potential to cause significant disruption, but no one was quite sure what to do about it. Meanwhile, Russia's Roscosmos, traditionally known for its skepticism about collaboration with Western space agencies, extended an olive branch to NASA and ESA. The threat of Thri Atlas was too great for any country to handle alone, and with the comet's path uncertain, it was in everyone's best interest to pool their resources. The space agencies began holding daily international conference calls, trying to make sense of the comet's behaviour and formulate a joint plan of action. Behind the scenes, governments were also preparing for the worst. In Washington, D.C., a secret task force was convened by the White House to discuss potential strategies for mitigating the threat. The global response was coordinated and strategic, but it was also deeply political. Every move had implications for international relations, and trust among space agencies had never been more crucial. The sense of urgency was palpable. News outlets around the world began to cover the comet's return extensively. While most were still focused on its potential to disrupt communications and satellite systems, the growing concern about its impact on Earth was beginning to seep into mainstream media. As the comet's trajectory became clearer, the question on everyone's mind was, how close would it get to Earth, and what would happen if it passed too close? It wasn't long before the worst-case scenario began to unfold. On November 22, 2025, NASA confirmed that the comet had released a burst of radiation unlike anything they had ever observed. The radiation blast hit several key satellites, disrupting communications and navigation systems. The effects were immediate. Weather forecasts went haywire, global shipping routes were thrown into chaos, and GPS systems failed. The economic implications were catastrophic. With major transportation networks thrown into disarray, companies began losing millions of dollars per day. Stock markets around the world plunged as uncertainty about the comet's path intensified. Businesses that relied on satellite technology scrambled to find backup solutions, but many systems were already down. In addition to the economic fallout, the psychological toll began to mount. People across the globe felt the uncertainty in their bones. What had once been a distant celestial event was now affecting their everyday lives. Power grids flickered, and rumours of larger, more destructive radiation blasts began to circulate. It was clear that the comet wasn't just a curiosity anymore. It was a force that was already changing the world. Scientists still working to understand the full extent of the damage grew increasingly concerned about what would happen next. What if this radiation wasn't a one-time event? What if the comet's approach caused more harm as it came closer to Earth? The stress on those working to protect the planet was immense, but it was the fear of what might come next that kept everyone on edge. As Thri Atlas continued its approach, the world braced for what seemed like an inevitable showdown. Nations began to issue public warnings about the possibility of widespread disruptions. Governments pushed forward with contingency plans, preparing for everything from further satellite failures to worst-case scenarios involving the comet's direct impact on Earth. In the United States, military forces were placed on alert, ready to provide assistance if needed. Shelters were built in key locations around the country, and the government began to instruct citizens to stockpile supplies in case of an emergency. People were no longer asking if the comet would have an impact, they were asking when. As the global panic spread, the personal toll began to show. Scientists working on the mission spent sleepless nights trying to predict the comet's exact path, their families anxious about the outcome. For those involved in the operation, the emotional strain was overwhelming. They had dedicated their lives to studying space, yet now they were faced with the possibility that humanity itself could be in danger. The panic also took hold of ordinary people. Families began to wonder if the worst was truly coming. Was it time to prepare for something much larger than a mere disruption of technology? Could this be the end? As the comet approached, the sense of foreboding deepened. Humanity was facing something beyond its understanding, and the world on edge was holding its breath. As the comet 3EI Atlas hurtled closer to Earth, time was no longer a luxury. Space agencies around the globe worked tirelessly to monitor its every move, trying to piece together the puzzle that had been placed in front of them. What had once been a theoretical problem, a comet on a collision course with the solar system, had evolved into an immediate, pressing reality. The speed of the comet was growing exponentially. Data from independent astronomers and space agencies confirmed that the comet was not only accelerating, but doing so in a manner that defied traditional understanding. NASA's top scientists were scrambling to understand what was happening. Dr. Michael Harrington, the astrophysicist who had first raised alarms about the comet's unusual behaviour, was now leading a team of specialists tasked with deciphering the new data. The more they analysed the comet's trajectory, the more they realised that this was no longer just a distant threat. The comet's path was moving faster than expected, and it was heading for an unprecedented close encounter with the Earth. But could they stop it? Space agencies across the globe, ESA, JAXA, Roscosmos, all joined in a unified effort. The consensus was clear. The comet's increasingly erratic behaviour meant that all options were on the table, including the unthinkable, attempting to deflect it. A wide range of plans were being discussed. Some advocated for using nuclear payloads to disrupt the comet's course, while others suggested a more measured approach, launching a massive satellite designed to nudge the comet off its path using gravitational forces. As each plan was laid out, there were murmurs of doubt. Could humanity really alter the course of such a vast celestial body? Meanwhile, governments around the world were preparing for all possible outcomes. The reality of the situation was beginning to sink in. The comet wasn't just a scientific curiosity. It was now a matter of survival. In Washington, D.C., the National Security Council convened daily meetings to address the crisis. Leaders in Europe were meeting with emergency response teams, organising mass evacuations, and planning for potential infrastructure damage. Every country on Earth seemed to be bracing for an impact they couldn't fully understand. Military forces around the world began preparing for what could be the largest operation in history, a race against time to either prevent or mitigate the impact of 3I Atlas. The uncertainty of the comet's speed and trajectory made everything more urgent. What had once been weeks of preparation were now mere days. Time was running out. As the comet neared, the fear was palpable. In the media, in the newsrooms, across social platforms, and in conversations between loved ones, the same question was repeated over and over. What happens when it gets here? Could humanity do enough to change the course of this disaster, or was the cosmic clock ticking toward an inevitable conclusion? The true nature of 3I Atlas began to reveal itself as scientists uncovered more disturbing findings. What had initially seemed like an ordinary comet on an unconventional trajectory had evolved into a cosmic enigma that stretched the limits of human understanding. As NASA scientists continued to study its unusual path, they made a discovery that would change everything. Dr. Alice Thorne, the lead astrophysicist at NASA, was the first to notice the anomaly in the comet's composition. Over the course of several weeks, her team had been working to understand the comet's behaviour. With its radiation bursts and accelerating speed, 3I Atlas had already been classified as highly unusual, but now something even more startling emerged. The comet's core wasn't just a mass of ice and dust. It was something far larger and more complex. Through their observations, Thorne and her team discovered that the comet's nucleus was unlike any comet they had ever studied. It was dense, and its composition didn't match the usual pattern of frozen water and rock. Instead, they found traces of heavier elements that suggested the presence of something far more massive, possibly the remnants of a larger celestial body. Was it possible that 3 Atlas was not a comet at all, but a fragment of a much larger object? The theory began to take shape that 3 Atlas could be the fragment of a long-lost star, or perhaps the remains of a supernova that had exploded billions of years ago. The implications of this discovery were mind-boggling. If this was the case, the comet was not merely a passing object, but something that had been lurking in the cosmos, potentially for eons. This wasn't just an interstellar visitor, it was a cosmic relic, a piece of ancient space history that had been wandering through the galaxy before being pulled into the sun's gravitational field. This discovery opened up a terrifying possibility. The comet's behavior, its acceleration, its strange emissions, could be a sign that it was not simply following a natural trajectory. It could be part of something much larger, something that had been set in motion long before humanity had ever existed. Could it be that 3 Atlas was a fragment of a rogue star, capable of triggering forces that humanity was not equipped to handle? The very fabric of scientific knowledge was being challenged. The laws of physics that had governed the behavior of comets for centuries were no longer enough to explain what was happening. It was a revelation that sent shockwaves through the scientific community, sparking debates that stretched far beyond the scope of the comet itself. Was 3 Atlas a warning? Was it pointing to something larger in the universe, something humanity was not yet ready to understand? As the mystery deepened, one thing was clear. This was no ordinary comet. It was a force that was rewriting the rules of the cosmos. As the comet's approach grew closer and the implications became clearer, societies around the world began to react in starkly different ways. Some governments and organizations remained hopeful that humanity could do something to alter the course of events, while others struggled to keep order as panic spread. The global community, once unified in its pursuit of scientific knowledge, was now divided in its response. In some countries, the sense of fear had become almost palpable. Citizens stood in long lines outside stores, buying supplies and preparing for the worst. Shelters were built, emergency procedures were outlined, and plans for evacuations were laid. In major cities, television broadcasts and news outlets shared dire predictions, causing widespread anxiety. People couldn't help but feel that they were helpless in the face of a force they couldn't control, a cosmic visitor that had the potential to destroy everything in its path. Meanwhile, other nations, particularly those in more developed parts of the world, took a more pragmatic approach. Governments scrambled to fund space projects that could deflect the comet, and scientific teams worked tirelessly, trying to find a solution that would prevent disaster. In these places, a sense of cautious optimism began to emerge. Could humanity's ingenuity be enough to avert catastrophe? Was there still time to find a solution? The divide was not only political or scientific, it was emotional. Some people clung to the hope that human technology could save them. Others, gripped by fear, prepared for an inevitable end. The media, rather than calming nerves, seemed to fan the flames of panic, speculating on the comet's potential to bring about global chaos. As families tried to prepare, the reality of the situation began to take hold. There were no guarantees. The comet's approach was unpredictable, and while scientists and governments worked around the clock to find a solution, no one could say for sure whether they would succeed. But amid the fear and uncertainty, a deeper, more philosophical shift began to take place. People started reflecting on the nature of humanity and its place in the universe. If this comet was part of something larger, something older and more powerful than Earth itself, then perhaps humanity was simply a small part of a much bigger picture. Could this be the moment when humanity had to confront its own vulnerability, its own insignificance in the vastness of space? This realization both terrified and humbled the world, uniting people in ways that had never been imagined before. As the comet neared, the world seemed to hold its breath. The frantic activity of the previous months began to settle into a tense quiet. Space agencies, governments, and civilians alike waited in a state of suspended animation. There was nothing more to do but wait. The comet was now within range, and the best humanity could do was watch and prepare. In laboratories and observatories around the world, scientists continued to monitor the comet's every move. The data was streaming in, but there was little they could do to alter its path. Dr. Alice Thorne stood at her telescope in the quiet of the NASA facility, her eyes trained on the comet's steadily advancing approach. The numbers on her screen flickered, and her mind raced through the possibilities. There was no way to turn back the clock now. Whatever would happen next, it was coming. Meanwhile, in homes across the world, people were coming to terms with the inevitability of the situation. Children looked up at the sky with a mixture of awe and fear. In quiet moments, families gathered together, reflecting on the fragility of life, the uncertainty of the future. Would they be around to see the comet's passage, or would this be the end of everything they knew? The final days before the comet's closest approach were marked by a haunting sense of calm. There was no more urgency, no more frantic action. The quiet was deafening. The world waited, holding its breath as the comet neared its greatest point of danger. People wondered what, if anything, would happen once it passed. Would it change the course of history forever? The day arrived. The Comet 3 Atlas was now less than 100,000 kilometers from Earth, its final approach coming faster than anyone could have anticipated. The planet held its breath, and the world's collective gaze was fixed on the sky. Was this the end? Or was humanity about to witness something even more profound? The questions echoed throughout the world as the comet loomed ever closer. Scientists, their faces tense and strained, monitored the comet's approach with dread. It was too late to turn back. The options had all been exhausted. The comet's radiation had already wreaked havoc on satellites. The possibility of catastrophic solar flares seemed more likely by the hour. And yet, as the final countdown ticked away, there was still no certainty. What would happen when it reached Earth's orbit? Would humanity survive? The comet's closest approach arrived without warning, leaving the world on the edge of its seat. Time seemed to stretch as the universe held its breath. The final impact, the cosmic collision, would change everything. When the Comet 3I Atlas finally passed by Earth, there was no cataclysmic impact, no fiery destruction. The world collectively exhaled as the danger faded into the distance, leaving behind only the lingering echoes of uncertainty. Earth had survived, but the full consequences of the comet's approach were still unravelling. Something had changed, not just in the immediate environment, but in the very fabric of how humanity viewed its place in the cosmos. In the days that followed, scientists from all over the world converged to analyse the lingering effects of the comet's close pass. The radiation bursts, which had caused widespread communication disruptions and chaos on Earth, had left behind a subtle but undeniable imprint. Satellites were damaged, some irreparably, and the electromagnetic fields around Earth had been subtly altered. The comet's wake had scattered traces of high-energy particles that created unexpected phenomena in the atmosphere. Aurora borealis displays were seen across the globe, and strange weather patterns emerged as the Earth adjusted to the new forces it had experienced. But despite the physical aftermath, there was also a psychological shift. The threat that had once loomed so large, causing panic and fear, now seemed distant and almost surreal. Yet, as the world returned to a semblance of normalcy, it became clear that the impact of 3I Atlas was more profound than anyone had anticipated. The comet had awakened something deep within humanity, a sense of vulnerability but also a sense of unity. People had come together in ways they hadn't in decades. The shared experience of surviving an unseen cosmic threat had become a unifying force. This was not the end of the story, however. The lessons learned from 3I Atlas were shaping the future of space exploration. It had become evident that humanity was not invincible, that the cosmic forces that had shaped the universe for eons still held an undeniable power over Earth. Yet the comet had also demonstrated that humanity's resilience, adaptability, and ability to rise to a challenge were unmatched. The question now was, how would the world move forward? What would this experience teach us about our relationship with the universe, and how would it change the way we prepared for the unknown? In the weeks after 3I Atlas passed by, humanity found itself grappling with questions that went far beyond the immediate survival of the planet. The fear that had once gripped the world began to give way to a deeper reflection. What had this experience really taught us? Was the fear of the comet justified? Had humanity overreacted or underreacted to the threat? For some, the event confirmed the worst fears about our fragility in the vastness of the cosmos. It served as a humbling reminder that, despite our advancements, we were vulnerable to forces far beyond our control. The universe, vast and unknowable, had reminded us of our insignificance in the grand scheme of things. The comet had come from the depths of space, a silent traveller with the power to disrupt everything in its path. Humanity's dependence on technology, satellites, communication systems, GPS, had been laid bare. The near disaster had shown how fragile our interconnected world truly was. But for others, the aftermath of 3I Atlas sparked a more optimistic reflection. The comet's passing had proven something even more important, that humanity was capable of responding to the unknown. We had acted with urgency, determination, and most importantly with collaboration. Nations had worked together, pooling resources, sharing knowledge, and supporting one another in ways that had been rare before. The comet's approach, though, terrifying, had been a test, and humanity had passed. The real question now was how we would build on that success. How would we take the lessons learned and apply them to our future endeavours in space? In the quiet reflection that followed, many began to question the role of technology and the space agencies in preparing for such events. Was humanity over-dependent on technology, expecting satellites and spacecraft to handle everything for us? Or had space exploration simply not advanced enough to detect and handle such threats in time? The fear that the world had felt in the months leading up to the comet's approach was not just a fear of destruction, but a fear of the unknown, the vast, uncharted territories of space that humanity had barely begun to explore. The event had, for the first time in a long while, united the world in a shared vulnerability. But it had also highlighted an undeniable truth. Space was not just a scientific frontier, it was a life-or-death battleground. As humanity began to process the near miss with 3I Atlas, a new sense of urgency emerged within the global space community. The comet had revealed profound vulnerabilities in our understanding of the cosmos, and there was a widespread consensus that humanity needed to change its approach to space exploration. Space agencies, once focused primarily on scientific discovery and exploration, now turned their attention to planetary defense and the preservation of life on Earth. NASA, ESA, JAXA, and other space agencies began to revise their priorities. The focus shifted from pure exploration to more practical survival-based missions. While the excitement of discovering new planets, moons, and asteroids remained, there was now an understanding that the universe was full of potential threats, and the comet was just the beginning. The global community began to pool resources into developing new technologies that could detect and potentially deflect hazardous objects from space. Space telescopes were upgraded to identify incoming objects earlier, and international partnerships grew stronger, as nations realized that the defense of the planet was no longer something one country could do alone. Private companies, such as SpaceX, Blue Origin, and others, also pivoted their goals. No longer were they focused solely on space tourism or exploration. Instead, they began investing heavily in asteroid and comet impact mitigation strategies. New spacecraft capable of intercepting and altering the course of dangerous celestial bodies were designed and tested. The first private-public space missions dedicated to planetary defense were launched, ushering in a new era of cooperation and ambition. The world's space agencies, bolstered by the near disaster of 3I Atlas, also turned their focus to deep space exploration. The realization that the universe was full of unknown dangers encouraged governments to fund new missions to study the far reaches of space, not just for the thrill of discovery, but for the practical need to understand and protect Earth. With new technologies in place, humanity was now looking outward with a sense of purpose and resolve that had not been there before. The passing of 3I Atlas left an indelible mark on humanity. For the first time in history, the world had faced a universal threat that didn't discriminate based on nationality, race, or wealth. The comet had brought people together in a way that no political leader, no war, no disaster had ever managed to do. Governments, private organizations, and civilians had all rallied around the shared goal of survival. The global response to the comet's approach revealed a profound shift in the way humanity viewed itself. Gone were the divisions that had long plagued international relations. The geopolitical tensions that had once seemed insurmountable now appeared petty in comparison to the vastness of space. The comet had taught humanity that survival and the future of the planet depended on cooperation, not competition. Space agencies, once fiercely independent, now worked in tandem, sharing information, resources and technology with an openness that was unprecedented. It was no longer just about national pride, it was about the survival of the species. The global solidarity that emerged after 3I Atlas's passing also reshaped the way people viewed one another. The fear that had once been felt so deeply by individuals was now shared. Across borders, across continents, people found common ground. In the face of the vast unknown, humanity had learned to stand together rather than apart. The unity born from the threat of the comet was not something that could be easily forgotten. For the first time, people saw themselves not as isolated individuals or nations, but as a collective species. A species that, despite its differences, could achieve incredible things when it worked together. The comet's close call had been a wake-up call, but it had also been a lesson in resilience and hope. Humanity had survived, not by conquering space, but by learning to cooperate in the face of its most daunting challenge yet. As the world slowly returned to a state of relative calm, the future began to take shape in new and unexpected ways. The near miss with 3I Atlas had forever altered humanity's trajectory, both in terms of space exploration and our relationship with the universe. The comet had shown us just how small and fragile we were in the grand scheme of things, but it had also given us a profound opportunity for growth. In the years following the comet's passing, space agencies around the world accelerated their efforts to expand humanity's reach into the stars. With new technologies in hand and a collective resolve to explore and understand the cosmos, humanity began planning missions to other planets, moons, and asteroids, not just for exploration, but for survival. The ambition to colonize other worlds, once a far-off dream, was now seen as a necessity for the future of the human race. The comet had also prompted a philosophical shift. No longer were we a species focused solely on technological advancement or economic gain. The urgency to protect Earth, to understand the universe, and to prepare for the unknown became central to human progress. Space exploration was no longer a luxury or a hobby. It was a matter of survival. As we looked to the future, the lessons of 3I Atlas resonated deeply. The importance of collaboration, the resilience of the human spirit, and the undeniable need to continue learning, exploring, and preparing for the unknown. The comet had taught us a simple but powerful truth. The future was not written in the stars. It was in our hands. And so, with renewed determination and hope, humanity set its sights on the stars. We had faced the ultimate test, and we had come out stronger. The cosmos was vast, full of potential threats and mysteries, but it was also full of opportunities. The future, once uncertain, was now a horizon filled with promise,